Welcome to our tutorial on building a text generation model using Java. Today, we will walk through the entire process step by step, empowering you with the knowledge to create your very own language model. Before we dive in, let's briefly discuss what text generation is and why it's such an exciting field. Text generation refers to the AI-driven process of creating human-like text based on a given input. It has applications ranging from chatbots to content creation. In this video, we will be creating a simple text generation model using a dataset, and we will implement it step by step using Java. We'll discuss the requirements, the approach we're going to take, and how to put everything together. Let's start by listing the prerequisites. You will need a Java Development Kit, JDK, and we'll be using Maven for dependency management. Install a text editor or an IDE, such as IntelliJ IDEA or Eclipse, to write our Java code. Now, let's create a new Maven project. Open your terminal and run the following command to generate a new Maven project. Next, navigate into your project directory. You should find a basic structure with the main application file located at src/main/java/com/example/textgen/app.java. Let's open this file. To build our text generation model, we will be using a popular library called Deep Learning 4J, which is a robust tool for machine learning in Java. We need to add this library as a dependency for our Maven project. Add the above dependency snippet to your pom.xml file between the project and /project tags to include the Deep Learning 4J library. Make sure to also include the following dependencies to support your model's training. Now that we have the necessary libraries, let's prepare our dataset. You can use any text data you have or find a dataset online, like Project Gutenberg or news articles. For illustration, we will use a simple dataset of sentences stored in a text file called dataset.txt. Let's prepare our Java code to read the dataset. We'll start by creating a class called TextDatasetLoader. This class will handle loading and pre-processing our text data. This class reads lines from a specified file and stores them in a list of strings. Now let's write the main method to utilize this loader. We will also display the loaded sentences. This code loads our dataset and prints each sentence to the console. At this point, run your Java application to ensure everything is set up correctly. With the data loaded, it's time to pre-process it. For our text generation model, we'll need to clean the text, tokenize it, and create a frequency distribution of the words. This method processes the loaded data, converting it to lowercase and splitting it into words while keeping track of their frequency in a map. Let's integrate pre-processing into our main method. Run the application again. You should see a frequency distribution of the words in your dataset printed to the console. This data will be useful for training our model. Next, we'll proceed to create a neural network model using Deep Learning 4J. Let's define our model architecture. Here we define a feed-forward neural network. It contains an input layer, a hidden layer, and an output layer. The Atom Optimizer is used for training. Next, we'll add a method to train the model using the data we have prepared. With our model defined, we need to prepare our data for training. Deep Learning 4J offers facilities to prepare datasets, which we will utilize in our text generation model class. We will apply tokenization so that the model can understand the words. In this function, we create training data from the sentences by tokenizing and converting them into a numerical format suitable for the model. Finally, we tie everything together in the main method to train our model. With the training incorporated into the main method, let's now run the application to train the model. Make sure the dataset is well-formed and accessible. Once the training is done, we'll implement the text generation functionality to utilize our train model. This will involve sampling words from the probability distribution produced by the model. Here, we prepare our GenerateText method, where we sample from the train model to create new sentences based on a given seed text. The actual implementation will require extracting the next word using the model's probabilities. Finally, let's test our text generation feature. We can instantiate our text model and call the GenerateText method using a sample seed sentence. Run your application again and see how the model generates text based on the provided seed sentence. Remember to tweak the number of words to generate for different outputs. Congratulations! You've successfully built a simple text generation model in Java. You've walked through data loading, pre-processing, model creation, training, and text generation. As a challenge, consider trying to improve your model. You can experiment with different architectures or training on larger datasets. The field of AI and language generation is vast, and there's so much more to explore. Thank you for watching. If you found this tutorial helpful, please like, subscribe, and leave a comment below about what you'd like to see next.